Okay, so this lesson is about determining the minimum sample size. So in this lesson, we are not going to be given n. So they're going to give us a margin of error, and we're going to find the smallest possible sample size to be within that margin of error. In real life, there are lots of times where that would be helpful for us because maybe we do not want our interval to be too large, but we're not willing to reduce our confidence level. So the only thing to do is to increase our sample size. But before we do that study, we might want to know how big does it need to be? And in real life, taking a larger sample costs money and takes time. So we want to get the smallest possible sample to be able to get within that margin of error. So we are going to, first of all, I'm going to write out my formula. Margin of error, we know. So our formula is point estimate plus or minus margin of error. And our margin of error has 2 parts. So we have, and we're talking about proportion. So our point estimate is going to be p hat, and our margin of error is going to be z star, and our standard deviation is this guy, p1 minus p over n. Okay, so this part is our margin of error. So we're going to go margin of error equals z star times our standard deviation, p hat, 1 minus p hat over n. And let's read through. So they're going to give us all the things except for n. You wish to estimate with 90% confidence. I'm going to write that down. Confidence equals 0.9. The proportion of U.S. adults who made one or more emergency room visit last year. A prior study claimed that 21% of U.S. adults had made one or more emergency room visits. So they're giving me that P in advance. I will note, if they don't give you a P, then we're going to use P equals 0.5. And that's because that's the most conservative number. So often they give you some from prior research, but in this case, but if they don't, you're going to use 0.5. What sample size must you use to be accurate within 3%? So we want our margin of error to be less than or equal to 0.03, so within 3%. So notice I have my margin of error, it's 0.03. But I don't have my z star yet, so I'm going to be plugging in everything except for n because we don't know n. That's the whole goal, right, is to solve for n. But I can find my z star by going inverse norm and then our area to the left. And to find that area to the left, we just take our confidence level. We say 1 minus our confidence level divided by 2, which in this case would be 0.05. And when I type that in, I will get 1.64. So my z star is 1.64. Here it is. So we did inverse norm, 0.05 as my area. So now I can plug 1.64 in for z. They also gave me the p or the p hat, and that is 0.21. 1 minus 0.21 is 0.79. And then now we are ready to solve for n. So we're just going to solve algebraically. So to get n by itself, I first have to get rid of this 1.64. So I'm going to divide both sides by 1.64. Come over here. So I'm just going to type in 0.03 divided by 1.64. And I get this big long number. Now I'm going to round to the thousandth, but not really. So I'm going to write it as a rounded number, 0.018. And now notice all I have left is this square root. I'm going to go ahead and clean this up as well. So I have 0.21 times 0.79. And I get 0.1659, 0.1659 over n. Okay. To get n by itself, I'm going to square both sides because we have this square root. I have to get rid of that. So we're going to go square both sides. My square root symbol goes away. Now, instead of squaring 0.018, I'm not really going to round. I'm just going to come up in my calculator. I'm going to grab that full value and then I'll square it. If you do not grab the full number or keep more decimals, you could end up with an n that's really far off, maybe 100, maybe more different. So you do not want to use your rounded value. I don't want to have to write 10 decimals, so I'm writing it rounded to the thousandth, but I'm never actually using that. I'm scrolling up and grabbing my non-rounded value. Okay, so notice our answer is e to the negative fourth. Remember, that just means that I need to move my decimal 4 places to the left, which means I will have 3 zeros out front. So that new number is 0.123, so 3 zeros and a 3. equals, now I just have 0.1659 divided by n. Again, I'm not really going to round this number later. I'm going to use this value and just scroll up. Now the way to get to solve for n is to multiply both sides by n. So I'm going to multiply both sides by n. And I end up with 0.0003n equals 0.1659. Now I will divide through by 0.003. And this is what I'm going to type into my calculator because now n's by itself. So I'm going to go 0.1659, but this is a rounded value. So I'm going to go divided by, I'm going to scroll up and grab that whole number. And so I have n is equal to 495.8. For n, you're always round up. Even if your decimal, your tenth, is below 5, we're still always rounding up because it's my smallest possible sample, and you can't have even 0.2. You can't even have 0.2 of a person. You would have to round up. So we are always round up for this. So our final answer then is our sample size must be greater than or equal to 496. Okay. So this process isn't necessarily difficult, but it is kind of tedious. So some students would really like to have a formula that does all of this in one step. I personally do not use the formula that does it all in one step because I would rather understand and then do the work than just have to memorize like a floating formula. But doing this same algebra, if we would have left all the symbols in, you end up with this. N equals P1 minus P over margin of error divided by Z star squared. So if you would rather memorize this formula and plug those in, you could totally do that. And I'll do this same problem as if you had memorized that formula. So for this problem above, if I were using this formula to solve, I could go N equals, you still would have had to solve for Z star. But then you could go P, which was 1.21, 1 minus P, 0.79, divided by my margin of error, which was given to us as 0.03, divided by Z star. I would have had to calculate that with inverse norm by hand, and that is 1.64. And then we would have to square that. So I really could type this into my calculator from the very beginning if you memorize this formula. So I could go something like 0.21 times 0.79. And then we could go, I wish I would have put here, darn. Oops. There we go. So 0.21 times 0.79. And we'll go parenthesis. That's what I want to do. There we are. 0.03. 1.64. Close the parentheses, square it. There we go. So if you wanted, you really could do it all in one step. Notice you get the same answer. You are welcome to memorize this. This is not how my brain functions. I would rather take this piece of basic information that we know about confidence intervals and solve algebraically. And that is typically how we show this work. But if you can memorize that formula, this absolutely is a little bit faster. All right, let's do another. When we do not have a previous study or historical data to give us a plausible point estimate, we use p hat as 0.5. That's what I had mentioned up here. So when there's no p given, you're going to use that 0.5 because it's the largest possible margin of error. It's the most conservative. All right, well, let's do the next one. So you're running a political campaign and you wish to estimate with 95% confidence the proportion of registered voters who vote for your candidate. Find the minimum sample size needed. I want to know what is my n going to be to estimate within 2%. So my margin of error then is 2% or 0.02. Now I know that I'm going to have my Z star, so I could go ahead and solve for that. Remember, you're going to go inverse norm, area to the left, so which would be 1 minus 0.95 divided by 2. Which is 0.025. That's what I'm going to plug in. When you type that in, you will get 1.96. So there's our Z star. Notice they didn't give us a P, and I need that. So when I would go margin of error equals Z star P, 1 minus P over N. I have my margin of error, 0.02. I just calculated my Z star, 1.96, but I don't have my P. And remember that we're told if you don't have one given to you, we're going to use 0.5. And that's kind of easy math too. 0.5, 1 minus 0.5 is still 0.5. And then over N. Now I'm ready to solve. So I'm going to solve algebraically. I'm going to divide both sides by 1.96. So in my calculator, I'm going to type in 0.02 divided by 1.96, and I get 0.010. 0.010 equals, so this part's gone. I just have square root. I'm going to go ahead and clean this up. 0.5 times 0.5 is 0.25 divided by n. I can't have the square root, so I'm going to get rid of it by squaring both sides. And so now I'm just going to hit squared. So there's my answer. It's e to the negative fourth. So we're going to move our decimal place 4 spots to the left, and which gives us 3 zeros out front. So I end up with 0.0001 equals 0.25 over n. Now I'm going to multiply both sides by n, and I get 0.0001 n equals 0.25. I'm going to divide through by 0.001. And so I have n equals 0.25 divided by this number. So notice this is already in my calculator. So I'm going to go 0.25 divided by, I'm not going to use this rounded number. I'm going to go up and grab the non-rounded one. There we go. And I get 2,400.99999. So I'm going to round up. So I know that n has to be greater than or equal to 2,401. And that's my answer. For the next question, it doesn't require us to actually do math. We're just going to be thinking through. So if we're going to create a 99% confidence, actually, never mind. I was thinking of a different sheet. It's just another one. So we're going to create a 99% confidence interval. So if our confidence level is 0.99, we're going to have to calculate that Z star here in a moment. We want a margin of error no more than 0.05. Historical data indicates that population proportion has remained constant at 0.64. What's the minimum sample size that we need? So then we want to know what is our sample size. So we're going to go, we do have to solve for our Z stars. We're going to go inverse norm. 1 minus our confidence level, which is 0.99 divided by 2, and that gives us 0.01 divided by 2, or 0.005. So that's what I'm going to type in to find Z stars. We're going to go second bars, inverse norm, 0.005, which is 2.58. So once we have that guy, we're ready to set up our equation and solve. So we have margin of error equals Z star times P, 1 minus P over N. Our margin of error is 0.05. Our Z star is 2.58. Our P is 0.64. 1 minus P then is 0.26. 0.36, just kidding, 0.36 over N. And now I'm ready to solve. So we're going to divide both sides by 2.58. So in my calculator, I'm going to type in 0.05 divided by 2.58. And that gives me about 0.019. So I get 0.019 equals, let's go ahead and clean this up as well. 0.64 times 0.36 gives me 0.2304. 0.2304 over n, but I don't want this square root symbol, so I'm going to square both sides. And so 0.019, I'm going to square it, and I get this guy, e to the 4, so I'm moving it 4 to the left, which gives me 3 zeros, so 0.00038 equals 0.2304 over n. Now, you may have noticed from above that our final answer is always, like you're just flipping, which you're welcome to show it. I can show it all the way. But notice that when we have, grab a when we multiply both sides by n and then divide through by this, what always happens is these two values switch places. So many students, knowing this pattern exists, instead of showing both steps, multiplying both sides by n and then dividing by 0.00038, will do both of those steps at once. I know that my n's going to end up on the left, and this number over here, 0.00038, is going to take its place. That does always happen. If you would rather show your work that way, it takes up a little less space to skip that step. That always does happen. All right, so when you multiply both sides by n and divide by 0.0038, you do end up with n equals 0.2304 divided by 0.00038. So I am going to type that into my calculator. 0.2304, and I'm going to divide by, I am not going to round, I'm going to reach up and grab. And I get 613.45. Even though this 10th place is below a 5, I always round up for these types of problems. So you're always going to round up. So your answer is n has to be greater than or equal to 614. On a multiple choice scenario, you want to pick the closest, like the closest possible one. Never go under though, because it has to be greater than or equal to this number. If you would have rounded at these 3 decimal places, your number here would have been way off. So just careful with the rounding. So really do go up and grab those values. And that is all for this lesson.